Forces problems involving pulleys around a table. Now this is a really difficult Mechanics 1 question. If you can answer this question, you really are going to be looking at a good score in your Mechanics 1 paper. This question is probably worth in the region of about 11 marks on a paper, and it's going to look at your skills to do with looking at forces around a particle, looking at friction, and you're also going to be using SUVAT in this question. So if you can answer this, you really are going to be looking at getting a good Mechanics 1 mark. So you may have to watch this video a couple of times to understand it fully. So it's two particles, A and B, of mass 0.4 and 0.8 respectively, are connected by a light inextensible string. Particle A lies on a rough horizontal table 4.5 meters from a small pulley which is fixed at the edge of the table. The string passes over the pulley and B hangs freely, with the string taut 0.5 meters above the horizontal ground. The coefficient of friction between A and the table is 0.2. The system is released from rest, and find the following bits. Now, the first thing to do, of course, with all Mechanics 1 questions is to draw a diagram. Now, you're going to have to draw a really quite big, quite clear diagram here. So, firstly, we've got our table. Okay, and we've got a pulley on the end of this table. Now, remember, it's a smooth pulley. If it's a smooth pulley, it means there's no friction around the pulley. And we've got our mass 0.4 here, kilograms. Now obviously its weight is 0.4 G. And from the table there's going to be a normal reaction. Okay, also we've got our particle B that's hanging over here with 0.8, and its weight is going to be 0.8 G. Let's just label the two particles so we don't get confused. So this one here is A and this one is B. Next, okay, so they're attached by a string which goes over the pulley and down to here. And this, because it says it's a light inextensible string, we know that the tension is equal in all parts. It also means the acceleration is going to be the same along the whole thing. Now if it's released, obviously it's going to fall down this way because B is going to send it down towards the ground. We're also told that the friction, coefficient of friction is 0.2. So coefficient of friction is 0.2. There's one more thing. It says in the question that it is a rough plane that the particle A is on, so we've got to think about friction, and as well we're told that the distance from A to the pulley is 4.5 meters, and we're told that the distance from B to the ground before it's released is 0.5 meters. And that is everything we can draw from the diagram. Right, next, we're asked to firstly find out the acceleration in the system. Now the acceleration is going to be the same through A and through B. So the first thing to do is to find out what the tension is and what acceleration is. So the acceleration, we're going to look at particle A to start off with. So if we're going to include friction, we've got to firstly find out what the normal reaction is, because remember that friction is equal to mu times R. So let's start off by finding on A the forces upwards. So acting upwards is R minus 0.4 G, and there's no acceleration in that direction. Remember, this is from F equals ma, so we're looking at the forces equals the mass times the acceleration. So the resultant is equal to 0.4 G. Next step is we can take that and find out what the friction max is. So friction max is equal to the coefficient of friction times the normal reaction, and the coefficient of friction is 0.2, and we just found the normal reaction to be 0.4 G. And if you calculate that, you'll find that it's 0.784 newtons. Now we've done that, Now looking at A, we can find the forces acting to the right. So we're going to go look back at the diagram. So to the right, we've got the tension, and acting against it is the friction. So we've got T minus the friction. Because it's moving, we're going to be looking at the maximum friction, and that's equal to the mass times the acceleration. Well, the mass is 0.4 times by the acceleration, which is what we need to find. Now for the moment we can't do anything more with that because we've got two unknowns in the equation. So what we now need to do is we now need to look at B and look at the forces acting on B. So let's take the forces upwards on B. So now we're going to be looking at B. So looking at B, resultant upwards. So if we just quickly go and look at the diagram again, you'll notice that the tension's acting upwards and its gravity acting downwards. So you've got T minus 0.8 g is equal to its acceleration, its mass times the acceleration. Now its mass is 0.8. Now if we remember, we're taking the forces upwards here, but it's going to accelerate round and down, so we're going to have to put minus the acceleration, so it's going to be minus 0.8 a. Right, now we can rearrange this to make T the subject, because we don't want to find out what the tension is, we're not asked to. All we're asked to find out is to find out what the acceleration is in the system. So we've rearranged that to make T the subject, and we're going to take this new line here and substitute it into equation 1. So next thing, sub T equals 0.8 g minus 0.8 a into number 1 to find out what the acceleration is. So number 1 now becomes, instead of T, it's 0.8 g minus 0.8 a minus 0.784 equals 0.4 a. And all we need to do now is to collect together the a's on the right hand side, so that'll be 1.2a because it's minus 0.8. So we're going to add it, and we need to change the minus 0.8g into 7.84 minus 0.784, which if you collect together that, you get 7.056 equals 1.2a. So a is equal to 5.88 meters per second to the minus 2. That's part A completed. Now, as I said, we're not asked to find the tension. If we were, all we'd do is take that acceleration and substitute it back into this equation here, if we were asked to find the tension in the system, in the string. So part B says the time taken for B to reach the ground. Now we're told that B is 0.5 meters above the ground, and it's starting from rest, so its initial speed must be 0, and we've just found the acceleration. So that should jump out at you that we're going to be using the SUVAT equation. So SUVAT, so we're now on part B. So SUVAT, so know the distance is 0.5, we know the initial speed 0, we don't know anything about the final velocity, we know it's accelerating at 5.88, and we're asked to find the time. Now if you remembered your SUVAT equations, you should remember that we're going to use S equals UT plus a half AT squared. So 0.5 equals, for the first bit, is 0 times the time. So that's going to be 0 plus a half times 5.8 times the time squared. So if you rearrange this, you'll get t squared is equal to 0.17 ... which you then square root to find that the time is equal to 0.41 seconds. Now remember, you can't have a negative time. So we've done part B, A and B now. Now the final part says find the total distance travelled by A before it comes to rest. Now this is quite a complicated part, and this is why I say if you can answer this question, you can answer any question in Mechanics 1. So, the first thing you've got to do is you've got to find out, on A, what speed it's at when B hits the floor. Because as soon as B's hit the floor, A is going to start deaccelerating. So at first, the maximum speed it's going to get is just as B hits the floor. So you need to find out what the final velocity first is of A before B hits the floor. So part C, start off with. So part C. Firstly, using SUVAT, we know what its initial speed is, it's 0. We want to find the final speed. We don't know what the distance is. We know the acceleration is 5.88, and we've just found the time it takes for B to hit the floor. That was 0.41. And if you're using your calculator, try and keep the answer you had from before, which would have been 0.41239 ... So, let's find the final velocity, which is V equals U plus AT. So, the initial speed is 0, the acceleration is 5.88 times the time, which was 0.41. Which if you do that, you get 2.4248 ... So that is the final velocity, the final speed that A is at just before B hits the floor. Now, the next thing we need to find out. Now B's hit the floor, we're not worrying about B at all. And once B has hit the floor, we just draw a quick diagram for particle A. You've got its normal reaction upwards. You've got its weight downwards of 0.4 g. Its mass is 0.4. But now the string which was pulling it along has now gone loose. So it's having no pulling effect on A. So the only thing that's slowing the particle A down now is the friction. So, just looking at finding the forces of A now in that direction, now all you've got is the friction, which we found earlier on was 0.08 g, times by 0.4 A, because that's from F equals ma, because there's no forces now acting on A in this direction. So, if you calculate that, you'll find that the deacceleration is minus 1.96. So that is now what the particle A is deaccelerating at. So now we can find out the distance it's travelled in the second part from once B has hit the floor. Now the distance here, so we're doing SUVAT again, so we've got S equals U, V, A and T. So we're trying to find the distance. We know the initial speed because we found that earlier on was 4248. We know that it's going to finish when it stops, it's going to be 0, and we know it's deaccelerating at minus 1.96, and we know nothing about the time. So this means we're going to be using V squared equals U squared plus 2AS. So that the V squared is 0, U squared is 2.4248 squared plus 2 times minus 1.96 times by the distance. Right, so if you rearrange this and sort this out, you're going to have, if you do minus 1.96 times 2 and add it across, you're going to have 3.92 times the distance is equal to 5.88. Solve that and you'll get 1.4 0.49912, which you can take as being 1.5 metres. Now, that is the distance it's travelled from once B's hit the floor to when it stops. Remember, in the first bit, we know that B has fallen 0.5 metres from the question. So the total distance fallen, total distance, is going to be the initial 0.5 metres it's travelled, and then the 1.5 metres it's travelled after B has fallen, which makes 2 metres travelled in all. Now, as I said, if you can answer that question, you are going to be getting a very good mark in Mechanics 1. I suggest you re-watch this video and jot it down yourself and try and spot how I've got every single calculation.